Good morning, afternoon, and evening, everybody. I'm Danielle McLean, Executive Director and founder of High Sky Society. I'm so excited to introduce this month's distinguished speaker. But first, I want to tell you a little bit about High Sky. We exist because 10% of transportation emissions are from aviation, and that number is expected to triple by 2050. We believe that hydrogen is the only solution to decarbonize aviation. There are three big challenges with implementing hydrogen for aviation. I call them the big three: infrastructure, cost, and regulatory. We work with aircraft manufacturers, fuel cell developers, hydrogen producers, and everyone in between to help lower the cost and availability of hydrogen. And of course, we work with government, industry, and other organizations to help develop a safe path forward to regulate this nascent space. High Sky Society holds free monthly webinars on the third Monday of every month. That's what you're at right now. This is High Sky Monthly. Distinguished speakers include folks from Plug Power, Universal Hydrogen, High Point, Highmark, Plasma Kinetics, Luftcar, and so many more. I can't even put into words how much I've learned from these webinars. So thanks again for all of our distinguished speakers. Past webinars are available on our website, highsky.org/shop. And I really look forward to seeing what we're going to learn in 2023 throughout these invaluable webinars. And finally, our flagship event, Flying High, is June 21st through the 23rd. This is the world's largest hydrogen aviation event. We are so excited. We'll have over 1,000 attendees, over 100 presentations, and the network is just going to be unheard of. So whether you're an industry professional or just looking to learn more about hydrogen aviation, Flying High will definitely have something for you. Sponsors can showcase their services or products to over 1,000 highly targeted attendees, or you can join over 100 speakers to do a presentation on your service, idea, or company. We cannot wait to work with you. Tickets are available now on our website. Get them. This event will sell out. We have a limited number of sponsorships and speaker slots available, so I encourage you to get in now so that you can showcase your technology or company or idea to over 1,000 highly targeted hydrogen aviation industry folks. It's a virtual event, but not Zoom. I can't wait to see you at Flying High. So now let's jump into High Sky Monthly.
Hi, I'm Drea Hickman, PR strategist and PR director and hydrogen strategist here at High Sky. And I will be here from time to time sharing announcements with you, and I'm responsible for your web experience. So I have a couple of questions for you today. First of all, I'd like to know how many of you are actually members of High Sky Society and have signed up on the website. If you are a member, please type 1 in the chat right now. And if you're not, please type a 2 in the chat. Thank you. Also, I would like to know, for those of you who are members, how many of you have seen? I'm seeing ones. Okay, I'm going to give you a minute to get some more 1s and 2s in here. How many of you are members? How many have signed up to be a member of High Sky Society?
1 for yes, 2 for no.
Okay. This is good.
Yeah, it's
Okay, I would just have another question. How many of you have seen the Discord server that we have on the site? It is called Hi Chat. It's under the drop down next to your login. How many of you have seen that? Type a 1 for yes, I've seen it, and a 2 for I have not. We would really like to walk you through this process of membership right now. For those of you who have not signed up, to go to highsky.org and sign up to be a member. We can share screen to. Okay, so. Got it? Yeah. Okay, so just sign up. You just screen. It's going to ask you it'll send you a verification through your messaging to make sure you become a member. Everybody's done this before. Pretty standard.
Yeah, and then so after you create an account up here, it's free. Then you'll see this high chat. And this is a centralized place where we can all share articles, news, comments, and all that. Okay, sorry, Dre, go ahead.
And it's also where we're going to have a really fun game, which we're going to have trivia questions basically, but they're kind of hard. And we're going to try to find out who the hydrogen gurus are among us. We will have prizes and awards, titles to be announced in the future. So if you would all get your membership in order and sign up, start following High Chat, you can contribute anything you want in High Chat, but be sure when you're there to answer the challenge questions, because we will be keeping score, and that'll be really fun. So that's it for me.
Thank you so much, Drea. And then one final question is, what do you all think about potentially moving Flying High to an in-person or hybrid event? And we have an opportunity to potentially have Flying High co-located with the UAS Summit, Expo and Summit. And these are some pictures from last year. It would be in October 2023. And it would be, like I said, a hybrid in-person and virtual. And so if you would be more interested in doing it in person or hybrid in October, put a 1 in the chat. Let me just put a 1 in the chat for in person or hybrid in October. Put a 2 for no. Put a 3 for you don't care. And if you're wondering, for those of you that have already purchased tickets, we would certainly honor the tickets you've already purchased. So you could transfer that to the October event. Colonel Nathan Diller will be at this. There's some senators. It is North Dakota. I did look up the average weather for North Dakota in October, and it's average 55 degrees with 4 days of rain. So it sounds like it would be pretty nice weather. I've never been to North Dakota, but it seems like there's like tons of synergy. So yeah, keep the answers coming in. Here's Colonel Nathan Diller. A 1 for yes, you would like to attend in person or hybrid. A 2 for no, you would not want to attend. And a 3 for you don't care. And again, this is for the hydrogen aviation, the world's largest hydrogen aviation event that will be taking place. We had it for June as an all virtual event, but we're considering moving it to October. So 1 for yes to that, 2 for no, 3 for you don't care. I'm just scrolling through the pictures of it would be co-located with this event, and I'm scrolling through the pictures of their event last year. So this is kind of what you could expect. As a plus, our people. So it'd be our people plus their people. And I think it'd be really cool because they don't really have like an eVTOL or AAM section. So it would be, I think, nice synergy because we'll have that at ours. Okay, just last chance. If you're just now catching the question, a 1 for yes, you would like to do a hybrid event in October. A 2 for no, you would like to remain virtual in June. A 3 for you don't care. And I do see a couple of people have their hands up. If you could wait until after our distinguished speaker, you'll have the chance to ask questions at that time. Okay, cool. And I'll send out a link to this. Okay, so now let me show you about LinkedIn. If you registered on LinkedIn, this registration on LinkedIn, all it does is sort of tell you about the event, but you can't actually join from LinkedIn. So what you need to do is click this link. So if I invite you on LinkedIn, you need to click this link, and then it will take you to this screen, and then you can click this link. I know it's a little bit tedious, but LinkedIn doesn't give us a way, and you got to actually fill this form out to get here. So apologies that you had to go through so many extra steps, but that's what we're working with LinkedIn. So now, just 1 second. Thank you for bearing with me. I'm just pulling up. I lost my, thank you all for bearing with me. I'm missing okay, I'm gonna wing it because I don't want to keep you guys waiting. Apologies to Johannes. For some reason, his bio is not on my screen anymore. But I think I can do this pretty good. I'm pretty familiar with what he's up to. So our distinguished speaker for today is Johannes Garbino-Anton, and I really hope I did not butcher your name, Johannes. Johannes is of NEX Aero, and Johannes has an interesting background in the H2eVTOL space. NEX Aero just raised almost 4 million USD, so really excited about that raise. They also have some connections to some other companies that are in this space, but I'm not going to speak too much about that. I'll let Johannes talk about that if he wants to, but this is definitely going to be a company that you want to watch. Like I mentioned last time, we had Plug Power, Universal Hydrogen, and Zero Avia on these very webinars back in 2020, and all of those companies just set world records this year. And I think we're going to see the same sort of thing with NEX Aero. So they're going to be a company that we're going to want to watch over the coming months and years. And so without further ado, please welcome Johannes Garbino-Anton. You can go ahead and share your screen.
Hi, Daniel. I hope you can hear me well.
Perfect.
Awesome. All right. Let me see if I can share my screen. Can you see it now?
Yep.
Awesome. Yeah. So Daniel, thank you very much for having me first, and yeah, a huge shout out for hosting this event. I think hydrogen aviation will play a huge role going forward in the future, and we are trying to kind of contribute to that a little bit and show what we are working on since almost 3 years by now. And actually right now we just arrived a few hours ago at Aero Friedrichshafen in southern Germany, right next to Switzerland at the beautiful lake of Constance. And the next week, the Aero Friedrichshafen will happen here, and we are invited to showcase our flying prototype and then also our mock-up here. So really exciting times for us. And yeah, we're building the team in parallel, preparing the next flight test campaign. So a lot of stuff happening. And yeah, happy to share a little bit what we are doing right now. So basically, we are focusing on developing the first hydrogen fuel cell optimized air taxi eVTOL. And I say optimized because we thought we can get away with a retrofit that is optimized for eVTOL, but we very quickly saw that the optimization really has to be on both ends. So designing the vehicle around the powertrain and vice versa, and only then you can get kind of the gains and the optimum from both worlds. Why we do it? It's quite obvious. Aviation is still a large growing market in general, so traffic numbers. And even though there was the pandemic in between, kind of the dip is already gone. And while other sectors are kind of defossilizing and decarbonizing in the coming 10, 20 years, aviation will be the last, way harder to decarbonize sector. And at the same time, when you look at, for example, the European vision, Flight Path 2050 for aviation, that asks for a very drastic reduction in emissions, particle, non-particle, and also noise emissions, while at the same time, and this is the big challenge, reducing the door-to-door times for most of the travelers below 4 hours, which even for Europe is a huge challenge. And we think that kind of the longer distance point-to-point air taxi can be one of the multifaceted solutions for that kind of mobility. This is kind of what we're developing in a nutshell. So according to EASA H2eVTOL, so basically just below 3.1 tons maximum takeoff mass, which allows us 4 passengers and initially 1 pilot, later on potentially autonomous, and then 5 passengers. With today's technologies, we see roughly 500 kilometers of range capability at high speed, so 260, 270 kilometers per hour, about 160 knots, let's call it, plus reserves, VFR reserves. And this is kind of the big challenge that most of the larger ones are trying to get to. And we see kind of the potential that fuel cells can bring here. And this is kind of a little bit kind of the comparison, kind of if you can do those 400-500 kilometer legs non-stop at high speed, then you can really do interesting city to city, region to region connections in Europe, in North America, and other places. We have started this from the very get-go, focusing on technology partnerships. So shout out to Intelligent Energy. I saw Jonathan, one of our point of contacts at Intelligent Energy from UK. They are really developing, from our perspective, the world-leading aviation-grade fuel cell stacks. And they were one of the very first ones, if not the first ones, to fly piloted aircraft powered by fuel cells back in 2008. And we love where their technology roadmap is heading, and we think that ours is aligned as well to that, and we can make great use of their high power density and energy density especially. And then one of our other partners is called Apus. They are also based quite close to us, just outside of Berlin. They are working on the fixed wing hydrogen fuel cell aircraft and other sustainable aircraft technologies, and they are kind of a long-term partner for us. And then we also have a few other partnerships coming up there that we have not announced yet, but let's say there are some quite interesting technology pieces out there that we try to stitch together in the near future and showcase them in a flying prototype to show where we think those technologies can go. This is our flying prototype, 25% scale, so right around 4-meter wingspan, just below 25 kilos for now. We are preparing to fly it with a subscale fuel cell system, also from Intelligent Energy, very soon. You might have seen the video on our homepage. It looks actually like a rendering, but it's real. I have a small video for you in a few minutes. And this flying prototype for us is really, we use it for engineering validation, basically. So it's not the first one. It's by now the 3rd generation of a larger flying prototype. And we try to validate our slow flight handling qualities, then the stability derivatives, we designed the aircraft so that it can also do a conventional winged takeoff and landing, which we think is a game changer regarding towards contingencies, potential problems in the vertical lift stations and so on. But also going from point A to point B, if you can do a conventional landing at one of them, then you can save a little bit of range and turnaround time. So this flying prototype for us really was kind of the pivoting point. Once we got it flying and understood that our modeling is on point and we can kind of scale this, we are now developing an 8-meter wingspan flying prototype that will have several hundred kilos of takeoff mass. That will then be the basis for our first product, which will be kind of a half-ton to ton takeoff mass long-range cargo drone, which will already be kind of in the range of technology pieces that scale into the passenger version and are kind of not limited to let's call it heavy drone technology. Yeah, a little bit about our prototyping progress. So as I said, our first flying prototype, it was a 2-meter scale. It, as you can see on the upper left-hand picture, it still had a different configuration, 6 lift stations, which were a kind of a local optimum, but then with a very complex wing geometry and also we started to optimize with our MATLAB model right around 32 parameters in an optimizer loop. And then we saw that we can actually get away with a better overall solution if we look at not only kind of the vertical lift optimum, but look at total mass, cruise efficiency, and so on. And that's how we ended up after like 4 iterations on the current configuration. Yeah, this is kind of the ones that we see as competition or kind of the other ones that we think are doing the right thing in the right direction. For us, shout out to Joby, they are really kind of a benchmark in how they approach technology solutions. And we think with the fuel cell approach and really the optimized integration, we can deliver on range that everyone is kind of trying to get to, because that enables either kind of a longer range point-to-point market, but then also very quick turnaround times, kind of keeping the aircraft flying during daylight time as much as possible and creating revenue. That's where we stand in our kind of big picture roadmap. So as Danielle, as you pointed out, we just closed our first funding round. Until very recently, we were fully bootstrapped. We now have a team of 6-7 people. We are onboarding a few more and hoping to grow towards 18 to 20 people before end of the year, and really pushing forward the technology development. And as also mentioned before, our strategy is always focused on the passenger eVTOL, kind of the long-range, high-speed passenger eVTOL, because there we see the biggest enabler for hydrogen powertrain. That having said, for us, we see that as a 8 to 9 year road, very capital intense, obviously. And along that way, our next flying prototype is then the proof of concept for the first product, which will be as I said, we hope to have it in the 1.2 ton takeoff mass cargo variant. We are in contact with several of the big logistic companies, and for them, right around 150, 200 kilo payload for ranges about 400, 450 kilometers is relevant to directly connect their logistic hubs within Middle Europe. And that's our first entry market, where we hope to be within the next several years. that's part of our team. Let's call it the core team. We are really proud of the team that we are building. It's quite tough to find really world-class engineers that at the same time have hands-on experience in building stuff and that are ready to quickly iterate on hardware. And that's our focus, that's our philosophy, to iterate fast, like in the spiral design with the software development, get hardware flying in a relevant environment fast. And that's why we are building the 8-meter wingspan prototype, where we can fly the aviation grade technology components like the motors, the inverters, the liquid cooled fuel cell, the flight controller, and so on, to validate the engineering early, get our learnings. There are a lot of assumptions that still need to be proven, and we like to do that as early as possible, and learn by that, move by that fast, and get forward. Yeah, now I hope that the movie works. That's from our last flight test campaign late last year, where you can see that by now. Yeah, so seeing that fly always gives me a bit of a smile. So our team, to give maybe a bit of a background, we come from the general aviation mainly. Also, my co-founder comes from Airbus, Rolls-Royce side, and we are bringing together also people from the automotive, power electronics. We have a great industrial designer, and we see that there's still a way to go in working efficiently across disciplines, and the innovation often happens between the disciplines, and this is where we try to really enable a good collaboration in our team and between our partners to really drive technology-based innovation, using new technologies. We, for example, used a lot of additive manufacturing in our prototyping, which allowed us to move way faster than we normally would have done with a composite airframe and so on. So that's how we go, and that's what motivates us and where we think we still have way to go. So that's kind of the quick presentation in a nutshell.
Wow, I love it. Thank you so much for sharing that video. I feel kind of spoiled because I have not seen that video before. So I feel like we're kind of getting a sneak peek. Thank you for that.
Yeah, actually a very small snippet of that is at our homepage, but we realized that is especially this jitter effect in between makes it look like a render. So that might have not been the best idea, but the prototype is here. So who happens to be at Aero Friedrichshafen, stop by at our booth. We are in Hall A7, right at the entrance. You kind of bump into us. And we also have our 50% mock-up here. So that has already the dimensions of what we are trying to bring to flight. Nice. Before end of the year, let's say, early next year. And yeah, that's where we stand.
Really, really impressive. If I saw that timeline correctly, were you guys just founded in 2022? And so in less than a year, you've raised 4 million and flown a 25% prototype?
Yeah, so we started in the mid of 2020 with
that makes more
concept.
sense. I was like, what are you guys doing over there?
No, sorry, we're not that fast. It took us more than a year to really get the concept right, and then more or less when we were able to more or less convince Intelligent Energy that we are a partner to talk with and that we can use their technology and get kind of the insights. And then our MATLAB model showed that we can close the case and that it starts to work with those right around 550 watt-hours per kilogram on the system level. And we can see the speed and the range with this vehicle, with the efficiency, we have a very efficient aerodynamic wing. Obviously, we are carrying a little bit more drag with the configuration we have, but we chose it very intentionally because we think this lift and cruise configuration has literally no tilting parts and nothing is moving except for the 10 motors, and that greatly reduces any other certification risk, basically. And so we fully focus on the powertrain integration and the overall efficiency. Cooling obviously is a very large challenge because low temperature deltas. And we think we have a few interesting potential solutions. We think it's not a one golden bullet, but several ones. And that's kind of where we focus our engineering on.
Got it. This is the time where if anybody has any questions, you can type them in the chat. I do see one. This is a good question. Is the 25% aircraft fuel cell powered?
Yes, not yet, to be fully transparent. So what we did is we got it flying late last year with a heavy battery, and that literally allows us to fly for 8 to 9 minutes, and then it almost falls out of the sky. So we only had it in hover flight and slow flight, but not a full transition. And now we are in the integration phase of the fuel cell system, preparing everything for that, and hope to get flying very soon. I don't want to tell an exact date, but very soon. And then this will allow us to have way more hover time, and then get the flight controller really dialed in solidly, and then go step by step into the transition flight, and then show endurance flight.
Cool. Santh has his hand up. Santh, I'll go ahead and let you ask your question.
Oh, thank you, Danielle. Hey, Jonathan, great presentation. Just want to understand a little bit about your hydrogen storage on board. What mode is that? Just solid, liquid, sub, gas? Thank you.
Yeah, fair question. So let's see. Initially we will go with pressurized hydrogen, and there is a local optimum. I will not shout out the number just yet, but there is one. And technology-wise, that will definitely be kind of the first generation that we build on. Long-term, there might be an interesting case for a cryogenic, so liquid system. But so far, the disadvantage is that if you are not flying the vehicle on a very regular basis, and there might be the case, especially in the very beginning, in the first generation of operation, that it will be standing there in between for a day or two. Then you start to have the boil off, so pressure rising, and you kind of have to let the pressure go, and then and also the technology pieces are let's say 5 ± years behind the classic pressurized gas and then condenser and so on. So long story short, for us, we will first focus on pressurized gas. Also there we have a few ideas. There might be some interesting trade-offs in the integration. Yeah, but we try to keep it simple on that side and then take it step by step.
Thank you. And I just want to add in, I forgot to mention this in the announcements. There's a course on liquid hydrogen and learnings from space. And this is something that High Sky Society is super interested. And the first episode of the course is free. And I'm going to put a link in the chat because according to Matt Moran of Moran Innovations, the boil off isn't as big of an issue as we think, based on what he did with NASA for 30 years. I just put the link in the chat. I hope it's helpful to anybody out there. And there will be more sessions and more collaboration between High Sky and Moran Innovation. So definitely check that out, and maybe that will help us. Ovi asked, let's see, how much hydrogen will you need on board?
Yeah. So we are mainly always running the numbers for the large vehicle. And for that, the number is still confidential because we know that there are a lot of other teams trying to run their numbers, and we don't want to give too much of a benchmark. But the short answer is it's not too much. So that's the nice part about a hydrogen aircraft. You don't have too much of a CG shift, even if you have the hydrogen stored right at the back of the fuselage, for example. So that increases some operational aspects. Yeah, that's maybe fair to say.
That's a safe answer. I like it. What is your overall power? This is from Vlad. What is your overall power architecture? It looks like you have 10 fans. Are these driven by a single fuel cell stack system?
We will probably have about 4 or 5 stacks, depending on then the continuous rating. That is still a bit of a moving target, since we are talking about kind of a long technology roadmap. But from our perspective, it makes sense to have several stacks. Then you have kind of redundancy, and then if you lose one, you have only partial power loss. Obviously, in an eVTOL, it makes sense to hybridize with a power dense battery for hover and contingency, and also kind of the non-linearities in between. So if there's a peak power demand, then you kind of peak shave it with a battery, and the response time is quite low. And so we size the battery for the hover contingencies. That is still a moving target also for an eVTOL. There are different assumptions around that. Also, if you look at the different configurations that kind of the leading companies are designing for. But yeah, it's definitely a hybrid system for us.
Cool. That was what we did in our flight testing as well in my previous company, Happy Takeoff. And so this is a question I have. When you're doing conventional, could you do that with all hydrogen? And then let's say, would you just not need a battery and then you could reduce some of that weight? Would there be 2 different, I guess, airframes or powertrains, depending if you want to do conventional, or would the same aircraft be able to do both? And then how would you account for, I guess, that dead weight of the battery if you didn't necessarily need it?
Yeah, I mean, that's a fair question. So definitely, it could do the conventional takeoff with just the fuel cell power, and then yes, you could leave the battery at home. The battery is actually not that heavy, so yes, you can save a little bit of weight. Maybe you can put another passenger on board. I mean, then the next question is, would you leave the vertical lift stations at home? So the hover booms is what we call it. But still, you would end up with an odd aircraft. So it's not the perfect aircraft, the perfect fixed wing aircraft. So in the end, it's probably not worth it. And yes, we are aware of what Beta is doing, and that might be a viable pivot for several reasons. But I mean, shout out to H2Fly and Apus. They are really doing great work for fixed wing aircraft in the general aviation space for Apus, and then also for larger aircraft with H2Fly. I have been working with and for H2Fly and what used to be the German Aerospace Center since 2012, I think it was, for quite some time. Amazing team, and they are really pushing the technology for fixed wing aircraft. Why we started this project is that we saw that the trade-offs are way different, at a way different corner in the design space once you have to optimize for vertical flight, because the mass sensitivity is so much higher, and then you end up with different kind of trade-offs, and at a different price point, different material, different kind of how much effort you can put into saving mass and efficiency. And that's what we're after. And we think we have built a great team that understands the vehicle and that understands the powertrain. And it's really hard because it's kind of like speaking different languages. But once you are willing to listen to the different cultures, then it's a lot of fun.
Oh, I love that. And for those of us that I know a little bit, but if you could, just obviously whatever's public, could you sort of describe how what you're doing is different than Beta, Joby? And also I love that you're part of the H2Fly team. And one of the first things I asked you when we met is like, how are you not competing with them? That's interesting. So yeah, what separates NEX Aero from Joby, H2Fly, and Beta?
Yeah, I mean, when we started it, we were not aware that anyone else is working on vertical flight combined with a fuel cell, and we still think it's a really big challenge. And in the beginning, people told us that it's stupid to take the most complex vehicle you can find and then take the, I mean, it's not the most complex powertrain, but it is a complex powertrain, and then trying to combine it. And we were not sure ourselves for the first 1.5 years if that's the case and if we would stop. But when we saw that the numbers are adding up and that the technology can make sense when you take the right approach, then it makes sense. And then we saw that our our research behind that is not that trivial or not that obvious, and that building the team that understands both worlds and making them work very closely together is kind of the necessary predecessor, and that we think we have built a world-class and are building a world-class team that can do this. It's not 100% certain, but we think we can. So it's a journey. We are aware that by now it is a bit of a more obvious choice. I mean, in between Zero Avia got big, H2Fly got a huge investment, obviously, also from Joby. Shout out to both, great teams. Also, Pipistrel is part of kind of the bigger picture. They are doing great work, and still we think we can deliver relevant technology pieces for that, and I think our vehicle design and how we approach it is proof to that. So we think we have a right to exist. We are more or less friends with those mentioned, and we see it as a friendly competition, even though H2Fly is very heavily focused from the very get-go also for large aircraft, so 40 to 100 seater. And cryogenic systems. We are not going after cryogenic systems at this point. And so there are different approaches. Some of them, without naming names, less ideal, not the names mentioned, but different ones. So we think our approach being very realistic and not kidding ourselves on the numbers, but still being ambitious with the technologies that we want to bring to flight.
Yeah, I think also you have the right to exist. You know, there's so many opportunities for hydrogen aviation, and I think it really comes down to your use case. And everybody seems to sort of be finding their niche and having a need to exist. So I don't think it will be, you know, one winner. I think it will be several. So it's definitely going to be exciting to look. Okay, I'm going to ask some of the questions in the chat because I've been hijacking the questions. Okay, so Ann Bumani, I hope I said your name right. What's the weight difference that you noticed from batteries? Whoops, I scrolled off of it. From batteries to fuel cell.
Yeah,
touched on that.
Yeah, I mean, with a 25% prototype that we're flying right now, it is a significant difference. So we are getting 15 to 16% lighter, but that's not the goal. So for the larger vehicle, we would not design to have a lighter vehicle, but to have more range and more energy on board, to go the distance faster. Because the problem with the battery vehicle basically is that you are very, very constrained with the amount of energy you can take on board. And that makes you fly very close to best cruise. So the longer distance you go, the slower you go. And then in the end, you don't want to trap a passenger longer than 1 hour 20 if you don't have a toilet on board. I mean, it's that simple.
I'm so glad that you brought that up. You know what? This was one of the things I used to say, like when it was like 2018, whenever the Uber white paper came out, and I was like, why aren't we considering a restroom as a woman? Like that would potentially be a deal breaker for me, to be 1 hour in something and I don't have a restroom. Yeah, so I'm glad that you acknowledge that, because that's going to be important, especially when we're talking about these longer ranges. Obi asks, if you considered a combustible hydrogen power plant, I think he means, have you considered a combustible hydrogen power plant versus a fuel cell?
Yes,
Great
yes.
question.
Yeah, yes, but I mean, we are in collaboration with and in talks with one partner that is not just doing electric motors, but then also gas turbines. And they are developing one that is hydrogen capable. And that made us think a little bit. But then our main motivator is to work on pieces that are aligned with a fully sustainable energy future. And batteries will only cut it up to a very specific point. And yes, that point will be moving in the future, but there will always be this large apprentices, like a niche market that where hydrogen makes a lot of sense, and where you can kind of do a mission that you couldn't do without it. And burning the hydrogen is less efficient. It still has some particle emissions, and from our end is kind of then it would be kind of an in-between technology, but it's not kind of the long-term goal. So once you have the hydrogen on board, it's way nicer to do it in a fuel cell. The fuel cell has a longer time between overhaul, potentially less noise, less vibration, less moving parts. The overall itself, even if you look at a PD6 with a hot section inspection, it's painful, and the total cost of operation of a fuel cell is really interesting. And if you think at degradation for battery cells and how many cycles you can put on it, and then how much kind of contingency you need over time, and so on. From our perspective, fuel cell is super interesting in the operational aspect.
Cool. Let's see. What altitude, Chris Wade asks, what altitude range will the aircraft be able to operate at? Yeah, I mean, it's like almost any answer, and I have to excuse for that. It depends. So and that's why we like to do this, because it's always a multi-factor optimization. And so basically, with the first generation system, we will limit it to flight level 150, because you need more technology pieces like a regenerative turbo compressor to go higher and still stay efficient. And from our perspective, is not that relevant, especially since the first generation will not have a pressurized cabin. So you are limited to flight level 120 more or less in commercial operation anyways. Yeah, but over time we think both is possible, and there will be use cases where it makes sense to go higher. Got it. Is that feet? Or that can't be feet, is it? Meters? Yeah, flight level 120 is 12,000 feet more or less. Yeah. Okay. Well, okay, gotcha. Yeah. Like, I know that can't be. I was doing something wrong. So right around 4 kilometers it should be. Gotcha. Let's see. How many hover and puller motors do you have? It looks very similar to supernal eVTOL. That's Armand. Yes, it actually looks a little bit similar to that. It looks a little similar to kind of the straight wing designs that you see by some others. And we saw that the industry is converging to that. And it was funny because it happened more or less in the last 2.5 years, where we were also converging kind of from a complex corner case configuration that has a lot of complexities structurally, mass-wise, build-wise, and then also certification-wise, in the kind of the testing of a limit load and ultimate load you want to do. It's always kind of a big risk to break the wing spar. Also induce torsion and aero elasticity problems. So from our perspective, keep it simple, and then make it efficient. That's what we believe in. And by the way, a little bit more towards the kind of overall strategy. When we started 3 years ago, there was no hydrogen strategy, no national one, at least in Germany, not in the US. There, in between, then Airbus announced a hydrogen strategy for their aviation pathway, and during that time we saw suddenly a lot of leeway that said, okay, continue and do this, and it makes sense, and now it almost looks obvious, and we know
that a few of the really big eVTOL companies are working on fuel cell solutions. And without naming them, but in the coming year and two, you will see a lot of those. And what keeps us going is we know that it will be very hard, and a retrofit will probably not cut it. And a clean sheet design still from the standstill, even if you have a lot of experience designing for battery eVTOL, is not an easy feat. And you need a lot of clever disciplines combined and then make it work. So I don't want to disencourage anyone, but yeah, we think we definitely want to do it. So
yeah, I couldn't agree more. I think I said just the other day, I was on a podcast or something. I said 2023 will be the year that we see almost all, if not all, of the eVTOL companies and airlines go into hydrogen. I fully believe that. It's once you keep doing the math, you will just naturally converge to it because you'll see this is better. Okay, next question. Jay, if you want, you could unmute and turn your camera on and ask it. By the way, if you all want to ask Johannes your question yourself, feel free to raise your hand. I saw Jay's camera on earlier, so I'm going to go ahead and let him. But yeah, take it away.
Yep. Yeah. Hi. Yeah, I was just wondering if you had gotten your test model to transition fully yet, or even if you did it diving, because I know that was a big challenge with Beta Tech, was getting the airflow to attach to the wing.
yeah, no, we have not fully transitioned yet. We have gone to about 30-35 kilometers per hour, which is quite slow. So we saw first aerodynamic controllability, but we didn't cross even the stall speed of our flying prototype yet. So that still has to be validated, and we are looking forward to that because we also want to see if we designed it for full natural stability. So according to the CS23 natural stability for fixed wing aircraft, which is a little bit on the conservative side. So yes, the VTOL might become a little bit smaller over time, but that's how we like to take it. We think that transition will not be a huge issue because what we saw was very encouraging, but that we will have to do very soon.
Thanks.
Sure.
All right, let's see. We've got a few more questions. Peter, would you like to ask your question, or would you like me to ask it? If you would like me to ask it, just don't turn your camera
why don't you
on.
do that?
Okay, then you got it.
Thank you very much.
Oh, Peter, we don't hear you. We did for a
Oh,
second.
I was just wondering, when you say you have a 25% prototype, what does that mean? I know that's industry jargon, but it's just beyond me.
Yeah, sorry. Yeah. We keep calling it like this because that's how our engineering assumptions started. We look at the overall dimensions, so wingspan basically. So we see that the full scale vehicle will have 15-16 meter wingspan. That's kind of the limitation to use normal helipad infrastructure, kind of a retrofittable infrastructure. And so the current one has 4 meter wingspan. And obviously the masses and the volumes will not go linearly with that. So that's why we are looking forward to fly the next one, because that can go way heavier into the ton class and then fly the relevant technology pieces that are scalable into the 3-ton class.
Thank you for that question, Peter, because we get in our bubble and we don't always know what our audience knows and doesn't know. I just learned the other day what a K type or K tube was. I don't even know if I'm saying it's a letter K. It has something to do with the hydrogen production. I didn't know what that meant, so it's good to ask. I didn't know if Johannes was talking about feet or whatever a minute ago, different units sometimes. So our goal at High Sky Society is to bring all of the relevant people together. We all speak in different languages, literally, and sometimes mathematically. And so it's important to ask those questions. So there's no such thing as a bad question. I think that was an excellent question.
There's a lot of inside baseball here.
Yeah, and we don't know we're doing it when we do it. So thank you for pointing that out. That was great. Okay, so then we have Armand says thanks, but you did not tell me how many motors you have. I think it was 10, wasn't it?
Yes, sorry. So yes, 8 lift motors and 2 cruise motors at the back. Yes.
It was also, I think you talked about it in the presentation as well. Nataniela, I hope I said that right, asks, what about scalability? What are your thoughts on bigger eVTOLs using a similar hybrid approach?
Yeah. So we do have a vehicle design that is not limited to this 3.1 tons, so 7,000 pounds more or less. That's kind of the limitation of the HC-VTOL class, which is quite similar to the FAA standards. Let's say we have optimized one vehicle design for number of passengers versus operational efficiency and cost. And that has more passengers, but I will not give the number yet. That's for later.
Interesting. Ovi, I see you have another question. Would you like to unmute and ask it, or would you like me to ask it? If you would like to ask it, you can just unmute. I'll give you a second. If you don't unmute, I will ask it.
Sure. Are you able to hear me okay?
Yep.
Yes.
Good. Just curious, how much more money would you need to raise in the next 2 to 4 years?
Let's see. So, I mean, there's this obvious wisdom that you need roughly a dollar billion to get towards certification of a passenger carrying vehicle. We think that can become a little bit less over time, not much. So more or less that order of magnitude I mean, we are almost like an early follower in the market. So huge thanks for everyone that is running in front of us and kind of paving the way with the authorities. EASA is doing a great job in being very open for new technologies. That hasn't been always the case, so that is something that we don't have to do from day zero, at least, so we can focus on that. There's a whole supply chain building up. So, I mean, Joby, for example, they were winding their own motors in the early days because they had to. And we see that now there are, I mean, we are talking with a handful of potential motor suppliers, each with some benefits and drawbacks, liquid cooled, air cooled, and so on. But if we stay flexible enough in our design, then we can tap into that supply chain, and we very carefully choose which technologies are that important to our design that we vertically integrated. And yeah, we have a few that are on the list and that we are also working on the bench. And also the overall vehicle validation and design is part of that. And that's why I mean, the vehicle we are flying has changed over time quite a bit. And to the best of our knowledge is right now the largest 3D printed flying aircraft out there. And that's that wasn't a goal per se, but that was just kind of, we needed it this large so that it can scale with most of the kind of validations into a larger area. And yeah, and the fastest way to build it, to get it flying, and to change the configuration was using that, for example.
Thanks. Now we have, okay, Armand asks, if you have 8 lift motors, why do you still need to make the wing generate lift?
All right. So let's see. So if you are in cruise flight and you can generate the lift by the wing, then you can use way less power just to kind of push the aircraft forward through the air, compared to if you would to have to continue generating the lift, not dynamically with the wing, but with the lift motors. That's why we still don't understand that there's one company out there that has a fuel cell vehicle that only has vertical lift stations.
I know exactly who you're talking about. And this is the analogy I like to use. Like, think about a kite made out of paper. Okay, think about a paper kite, and to make it fly, you could just tie it to a string and run, and it would take off by itself. But now imagine that kite crumpled up into a ball, and try running that with, you're gonna have to use more power. It's not gonna want to just fly naturally. So with the wings, it wants to fly, and so you don't need as much power.
Yeah, and roughly speaking, so each wing has a kind of a aerodynamic efficiency that you can express as a lift to drag ratio, so how far you can glide per altitude loss, and that order is similar to the amount of energy you can save per cruise. Not exactly, but close enough as a rule of thumb.
Yeah, exactly. Okay, so then Nasser asks, what kind of certification and safety challenges do you think by the way, Nasser, you can unmute and ask if you'd like. Anybody can. I apologize, I haven't been saying that to everybody. If you'd like to unmute and ask it, go ahead and unmute now. Otherwise, I will ask it. I'll just give you a second. Okay, I'll go ahead and ask, but feel free to interrupt me, Nasser, if you'd like to ask it. What kind of certification and safety challenges do you think you are encountering? Sorry if you have already talked about this before I joined.
Yes, certification is definitely one of the huge topics or focus points for us. In some of the projects, it is not looked at very carefully. For example, we think that software certification is underappreciated, the amount of effort that this will take, especially changing the software late in the certification process. Also, especially towards the flight controller and so on. But that would also be a topic for later. Certification in general, we think, is mainly driven by the complexity of all the systems on board. And yes, the fuel cell system is kind of a bit more complex than certifying a battery, but in a different way. The plus side is when you have a hybridized vehicle, you have more failure paths that can be redundant. So there are different trade-offs basically. So it's not only more complex, and some alleviations in the overall topology, but that has to be kind of modeled very early on, because what we saw is that a lot of the certification complexities are driven by the operational limitations. And so we very early looked into those certification guidelines and also in the operational aspects of the vehicle. And even part of the vehicle design is really driven by those corner cases. If all of your lift stations will have fixed wing, fixed props, or if some of them will have to be variable pitch, that is driven by one of the corner cases, without pointing at which one, in hover. And that's counterintuitive sometimes, but when you account for it very early on in the design, you can take efficient decisions based on that. And if you see it only late in the flight testing, then maybe in the next vehicle design.
Awesome. Skiff, you could unmute and ask your question. If you don't unmute, I'll ask it for you, and I'll give you a second to unmute.
Yes, I think it's best if I unmute here because it's a complicated question. So you said you're targeting the 3-ton limit that H2eVTOL provides. When you do a hydrogen propulsion system, the hydrogen itself is a very small proportion of the MTOW weight. Joby's targeting, or Joby's aircraft is about a 2-ton aircraft. They have a ton till that limit. Now, obviously, they haven't been able to go and occupy that space because the current battery technology does not allow them to increase the range sufficiently. So there's various optimization points when you do battery pack eVTOL aircraft. How do you perceive the risks of battery technology improving to allow them to have this increased range, additional battery pack that does bring them to the 3-ton limit?
Mm-hmm. Yeah, so we think about that not too much because there's a long way to go. I mean, ideally, we would like to take about 1,100, 1,200 watt hours per kilogram on a energy density on a system level on board to really fly at relevant cruise speeds. I mean, if you look at modern turboprop aircraft, then you would like to fly it around 240 knots true airspeed, and then you need a lot of energy on board, and that basically means that yes, the batteries will get better and allow for those ranges, but not at those speeds. And ideally, we would like to do greater speed because then you can do more revenue per time, do greater distances, but especially do it at higher speed.
Okay, thank you.
And maybe to add to that, the fuel cell systems that we see today still have a lot of potential in mass savings over the next decades. And not just the fuel cell stack itself, also the balance of plant, the whole subsystems. Cooling is a large issue where you can save a lot of mass or get a lot of mass added to the system, and so there's a lot of potential in the technology still left.
Thank you. Phil, would you like to ask your question? And after Phil is SM Alavi, if you want to get ready for being after Phil. And then Phil, if you don't unmute, I'll ask it for you. It's a pretty short question. I'll just go ahead. What is the current lift time for your fuel cells?
So I think the question aims towards how long we can hover with the current configuration. For the 3.1 ton vehicle, that's still a bit of an open question. Between 90 and 120 seconds is what we think that the authorities want to see hover contingencies, which if you ever have hovered a helicopter, feels like an eternity. So you can do a lot of kind of re-landings in that time. But still, that's kind of the contingency that we also would like to see from an operational side. There are some assumptions that are way more aggressive, that are way like in the below 40-second ballpark, which we think is aggressive.
Thanks. And I think it's important to remind everybody that it is a hybrid configuration, correct, with using batteries. So assuming during that hover, it would probably rely a lot on the batteries during that.
Absolutely.
That's because your batteries are better at doing high power functions.
Hi, Danielle. This is Danielle. This is Phil. That was a great answer to a question I didn't ask. I was wondering what the lifetime, not lift time.
Oh, it does say life. I'm so sorry.
Yeah. So, but it was a great answer to a question I hadn't asked.
Yeah, so I mean, lifetime is obviously a moving target, not just for the fuel cell stack itself, but also a little bit for subsystem components. And the interesting part is that it's really a very hard comparison to batteries, because batteries just have completely different dynamics of how many cycles do you put on it. But the more cycles you put on it, the less state of health you will get over time. So kind of this depth of discharge. The fuel cells that we are benchmarking and looking at, they have a really great potential for 10,000s of hours, potentially very long term, kind of time between overhaul or very minimal overhaul in between. And then looking at the operational cost, that can be a very interesting driver, because I mean, even the maintenance on those systems is very minimal compared to gas turbine or even the batteries that we would have to kind of let go every year.
that was a perfect example of why I like you guys to ask your questions, because sometimes I mess them up. All right,
Hi.
Armand, you're up.
Okay, so basically what I'm getting at is you have eight lifting motors, right? So with those 8 lifting motors, you have interface loads that are going to the wing. So you have 8 interface loads coming from those motors, and we are not with the fail safe, like one of these motors out, whether being inboard, outboard, or the most critical one. So these loads will be redistributed, and they're going to have peaks at these interface locations. So that's one side of this, right? Now you want to make a wing strong to support all that. And on top of that, you want to generate the lift. So you got to have more, different aerodynamic profile of the wing and put it there, get more drag. So, and then you have your fuselage interface with the wing. So you have another 4 fitting over there. Do you have any estimate of how much this wing will weigh after all these interface loads coming from the motors, fuselage, during the flight, with the flight inertia and flight aerodynamic pressure loads acting on this? Any idea how much would be the weight of this wing?
Yeah. I mean, structurally, we are looking at advanced composite, like RTM and similar. I wouldn't call it mass manufacturing methods, but kind of for composite aerospace composites, it's kind of mass manufacturing. And then if you look at the mass assumptions, that they are still in the known design space, let's say. Yeah. So also those lift hover booms, as we call them, interfacing with the wing. The wing will have 2 spars, front bar, spar, rear spar, and then interfaces. Those are well predictable in the masses. And yes, it will be a heavy vehicle compared to kind of a fixed wing aircraft without that. So I mean, the payload fraction is lower than with a fixed wing aircraft, that's for sure. But that's what you kind of have to trade. You have to leave a few passengers at home to get the vertical lift capability. But we do that very intentionally, because we think that if you need to have a change of mode of transport. And if you do that at a place that is near, with a footprint that is small, building a new helipad basically is a 50 by 50 meter grass strip, and then some 20 by 20 meter asphalt. And if you want to do night landings, you need like 4 bulbs. And that's literally what you have in Europe at every second hospital. Yeah. And that's, for us, from our perspective, that's kind of the large enabler compared to, we haven't seen a new general aviation airfield being built recently, except for 1 or 2 exceptions in the last 60 years in Germany, at least. So for us, this kind of close to the communities, point-to-point vertical landing is a huge enabler in how this mode of transport will interact with the other mode of transports, and that this trade-off makes a lot of sense. But yes, it will be a heavier vehicle compared to a classic fixed wing aircraft.
Yeah, because those lift to weight ratios and L/Ds, by the time
Absolutely. We will not have 25 L/D. That's for sure.
Okay, thank you. Thanks.
Absolutely.
Yeah, and that I apologize if I did not mean to insult your intelligence, Armand. Again, this is why I like to encourage you all to ask your questions, because you're going to have more insight into them than I will. Alavi,
I appreciate that.
Yeah, you bet. Alavi, would you like to ask your question? I will give it a try if you don't unmute. Forgive me if I butcher it. Could you share a little bit more about minimum required thrust each propeller should produce for your 5-passenger aircraft, propeller type and diameter?
That's very, very specific. So I would like to take it a little bit more general. That depends a little bit on the capability of the motor. So ideally, we would like to have below 1,800 RPM, for example, for the noise footprint, and have a large diameter propeller. The exact diameter depends a little bit on the trade-offs on how long the hover booms, how deep kind of the wing is, and then still having the aerodynamic interfacts between those minimized for noise, but also lift efficiency. So that there's still some design space, and we think the propeller design might be something we take in-house because it's not a point design anymore.
Got it. We probably have time. I think that we got to all the questions. If I missed a question, please. Oh, wait. Yes, Skip. We didn't do skips, I don't think. Okay, as you target the 3T limit for the
Yeah,
same
you did do mine.
There you go.
You did do mine.
Oh, I did. Okay, thank you. Cool. So, for all of you that are not aerospace engineers, or kind of got lost on some of our jargon, we definitely tend to get into the weeds on these webinars, which is exactly the reason why we launched the High Sky Pod, which is the podcast that we're doing monthly on our YouTube channel. I will send you a link to it, but on that we keep it really high level, and at Flying High we will also keep it pretty high level. So this if you felt like your head was spinning on some of the language that we used, fear not, we are simplifying it, but we need you all to ask questions so we know where to focus on simplifying. And let me just give you the link to our podcast so that you can, we kind of just share, stuff that we're interested in. And oops. Place. Let me just stick that in the chat. Okay, cool. All right, we've got a second for any last questions, if there are any. Johannes, thank you so very much. That was incredibly insightful. I learned a lot. I'm really excited to watch NEX Aero grow over the next year. It's going to be really fun to watch. It was an extremely valuable presentation. And do you have any questions for us, or does anybody else want to go, or otherwise we can get 8 minutes of our day back?
Yeah, Danielle, first, thanks a lot for having us from NEX, and for hosting this event. We see a lot of value in the technical exchange, especially between similar-minded teams. That's why we have been part, for example, on the Electric Aircraft Symposium at the West Coast since 12 years roundabout. I've been co-founding the E2 Flight Conference here in Europe to do exactly that. And it's great to see that now this conference is especially kind of designed to answer the hard questions that are in the H2eVTOL scene, basically. So huge shout out and fingers crossed for the future.
Yeah, likewise. And I've been at the Electric Aircraft Symposium for the last 3 years. So I'm surprised we haven't met.
No, I haven't been in the US since Corona started. That's
okay.
for sure. But before that, kind of when it
Corona.
was still earlier days, that's so starting 2010 around that was the time. Yeah.
Gotcha. Very cool. And shout out Mike Hirschberg. By the way, the conference we're talking about is through Vertical Flight Society, and I see Mike Hirschberg is on the call. And for those of you that don't know, High Sky Society is actually a spin-off from Vertical Flight Society. We started in 2020 during Corona, the H2eVTOL Council, and it got so much momentum that we ended up spinning off into this society. So yes, thank you, Mike Hirschberg and Vertical Flight Society, for all the collaboration. Thanks again to you, Johannes, and congrats on your raise, and best of luck to NEX Aero. And we look forward to working with you all in the future.
Thanks a lot.
Thanks.
Daniel.
Have a good week, everybody.
Thank you. Have a good day.
Bye-bye.